Hello and welcome. I'm Bill Wake. We're here working on a program to compare tunes for similarity. We did a lot of work last week straightening out the notion of basically the default length of a note. How long is its rhythm? And we basically changed to a scheme where originally we just tried to do everything in one pass. Now we have a two-pass version, and we got the note length working, but key signatures are still kind of using the old method, and we never really finished them. We only support the initial key signature, not changes in key signature. So I want to focus there today and probably the next couple of days. Okay, I did a little stuff offline. We had something with L in the tune header that wasn't quite activated yet. I turned that back on. We had been using TuneBuilder a lot, and I kind of reduced its visibility, let things like test the parsers more directly and so on. And then we also made Note able to change the key of a note. That's something we'll need to do this next phase. And just had a little time, didn't bother broadcasting it. So let's see. Let me run tests, make sure everything's okay. I'm getting some weird thing in my Xcode. I can't get this get diff thing turned off. It's really annoying. I'll try again. I mean, I thought that would be what did it. I mean, these things look normal. Yeah, I don't know. I mean, that seems like the right thing. But anyway, we got our test passing. All right. Let me find this K colon thing, or K. So in the header of the file, you can specify the key. And right now, I think we only do like K colon C, K colon D. We might do the minors, but we don't do other modes. But we support that at the header. You're also supposed to be able to modify it in the bulk of the music, and we don't support that yet. I'm not going to worry about all the modes and klezmer and Arabic modes or any of that stuff right now. I just want to get the basic tune name or basic scales handled. All right. Okay, so, well, and you also can have an empty key or none. I don't know. We haven't dealt with that either. There's so much complexity. I just, everywhere you go in music, there's just deeper and deeper possible complexity. I mean, I had no idea about this. Scott's Highland pipes have a key signature that, well, it really looks like the key of D, but it's so often there, they don't even bother notating the key signature to show it. Okay. And they put in G natural because it looks like it's a key of A, but it's not, because it's, it's like, oh, it keeps going. All right. So let's go back here, and I guess we'll look at the ABC parser. I probably just close all the stuff there. We're kind of in a new phase here. Okay. So the ABC parser. And here's this notion of a key parser. Let's see what it does so far. All right. Well, it's just keeping this thing of keys to accidentals, knowing that the key of G has one sharp and things like that. All right. So you match key of letter A through G in the set of sharp or flat, and we build a key. We don't support any other modes. And this is enough for, I don't know, make up a percentage if you want, but a lot of music that's out there is just written in normal keys, major. We use minor some, but not as much as major. So we don't cover everything, but we cover a lot. Okay, so we build a key. Basically, we just turn that into the name of a key. We look up the accidentals for it, and that's our key. All right. At the top level here, let's go down here. Okay. So this is the part, basically the file header. So the first thing in there must be an X. then we have a T, then we're in the tune header, and then eventually we see a K. And the K says we're now going to be in the tune body. So it's the last thing in the header. We basically call set key on tunes, and we set tune state. My theory is tune state is not the right way to do things at this point, and I wanted to track through that a little bit today and see what's going on there. So let's look at, well, let's see what happens with tune state. Okay, so that's defined up here. Tune state holds the key and the unit note length at this point. All right. I don't think the parser should necessarily be the one to hold it. That's why I'm suspicious of it. But here's tune state. Let's see who uses it. Okay. The real thing is this note line parser and note parser. Now that one I don't think is useful. Okay, but in any case, here's note line parser. We pass the tune state in, and let's see what it does with it. Tune state. Oops. Okay, it's going to hold it. Oh, interesting. It doesn't do anything with it. Okay, let's see who accesses this. It's private, so it shouldn't be anything. Okay, so note line parser, does it call note parser? It must take that somewhere too. Yeah, note parser and duration parser. Okay, we don't do anything with tune state. So let's take it out of here. Okay. Well, I think I can just take it out here. And we'll ignore it. Now somebody should be complaining. No? Okay, let's see if that affects anybody. I don't think it should. And I think this is coming about just kind of the original way we took a little bit of a path trying to pass state through the parser and all that stuff, and it's not really the way to go at this point. I'm not sure. It might have been a reasonable start. I don't know. It seems like it makes things more complex, but definitely in the mode we're in now with the two passes, most of this is really for the second pass to straighten out. Okay, so I'm taking that argument off. Let's see who breaks. Okay. Note line parser does not need tune state. Oh, so annoying. Okay. Is that the only one? Seems unlikely. Okay. Really was. Okay, so remove tune state from note line parser. And let's track that here too. I'm feeling like I've lost something here. Oh, I put this in already. Okay, this is 34. Okay. Remove tune state from note line parser. Okay. Now, the other one that uses it is note parser. And I think we'll find it's being used in here. I don't think we should need to use it here, but That's what we're doing. Okay, there it is. Yeah. So what happens is when you build a note, if you explicitly give it an accidental, say an F sharp, okay, then we'll respect that. We'll keep that accidental. But most of the time, if you write stuff, you write a key signature in the front, and the sharps and flats are implicit. So if I'm in the key of G, G has one sharp, F sharp, and if I write just an F, that F should be treated as a F in the key of G, which is an F sharp. And where's it getting the key? Well, it's getting it from key state. I think this should not happen here. I think this key should be, well, at least key of C, which has no sharps or flats. Maybe that notion of none should be coming in. I'm not quite sure. But yeah, I don't think this is the right place for this. I think what should happen is when you go through on our second pass, we should then apply the key to this. All right, so that's where I want to push us to. It's gonna take a while to get there. Hello, welcome. Are you making a clip for teaching programming? No, I'm really just, I've got a big project I'm working on, and I just broadcast that and share that. So I would hope if somebody had the patience, they could watch the whole thing and learn some programming techniques. But I'm not specifically making a clip for that. It's a good sized project. I may be using it for some refactoring teaching or something, but I think these videos are just they're more me doing it as I go, stream of consciousness kind of thing. So, but anyway, welcome. Please pop in with any questions you have, and happy to talk about it. All right. So anyway, we have this key here. Thank you. We have the key. I think it should really be like key of C, and then our second pass should figure that out. Well, our second pass is in what's called TuneBuilder. Okay. And TuneBuilder, at the end, once you've gathered all the information, you say make, and I think this could be, let's extract this. This make calls complete tune. I guess let's look at that. All right, so complete tune goes through this notion of events, and it is the second pass. So we go through the first time and we say, okay, I see a note, I see a rhythm, I see this, I see that. We put that in the event stream, and then we come through here and say, at least for the rhythms, this initial note length thing, we say, okay, the initial note length, by default, you're telling me about eighth notes. Okay, but you can tell me you want to make them quarter notes instead, or some other note. Okay, and so when you build a note, we're keeping track of the unit note length, but that can change. So one of the events is change the note length. And so maybe you started in eighth notes and now you want to switch to quarter notes. And so this keeps this running state, and we're using tune state here as well. But keeps the running state so we know when we create a note, what length should we use by default, and then we multiply the rhythm by the note length. So if you said this is a length of 2, it's 2 times the note length. So if it was eighth notes, 2 eighth notes is a quarter note, and we would make it a quarter note at this point. But in its stream of consciousness, it gave us relative timings. This is a 1, this is a 2, this is a 4, and only when we know what the note length is in the second pass can we update it. All right, and the same thing should happen with notes. Today we just take the note, whatever the note is, we just take it and adjust the rhythm. But we should also adjust the key. And I want to do that in a way that doesn't break everything while I'm doing it, and I'm not sure I can. What should happen is if the note is in a key and the key changes, we should be changing the key of the note. Okay, it's still, if it was F in the key of G, 1 sharp has F, makes it automatically F sharp. F in the key of D also is F sharp by default. F sharp and C sharp are in the key of D. And so there's no real change in the pitch of it. It's still an F sharp, but because of the changing key signature, it should be regarded as being in a different key. I don't know if it's very hard to know if you're overcomplicating things or not, but I think having each note know the key it's in is probably a good thing. You can theoretically switch keys in the middle of a measure. It's pretty unusual, but it could be done. And you got to switch them somewhere, at the start or end of a measure if you want it to be for a new measure. But a key signature, yeah, can be anywhere. So what should be happening is this note should be adjusted to the current key, but we don't track the current key here. Let me go up to initial state. Okay, initial state is tune state, and let's look at tune state. Okay, it has the key. It does track it. Yeah, this really could be a struct, I guess. But anyway, it tracks the key, but it's not applying it at builder time. And I think the only place it's applying it is in note parser. Let's get that thing back. Okay, I hate this. I wish it would just automatically open it. I haven't found an option for that. Okay, but in note parser, it's tracking the key. Yeah, sure. So what we're doing is I want to study tunes and compare them for how similar they are, and we built a feature already. Let me get that thing up. Let's get a text example file. Okay, so this notation is an input format called ABC, and the core of it is down here. You're just basically writing the note names, and then duration. So B2, A, the notes in this measure are BB, A, BA, G, F, E, D, E, F, G, A, F. And this is a bunch of versions of Deck the Halls, which is a really old tune originally called No Scaling, I guess. And I'm working with a amateur musicologist who's analyzing these versions of No Scaling. So I'm going to take this input format. Let me run. Okay, so I paste that in, and I'm going to I'll just generate the report, which is called a Parsons code report. And I haven't done much work on the UI yet, but what happens is it takes the song and it basically looks and says, is each note going down, up, or the same? So down, 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 repeat is the same, up, down, up. And if you know Deck the Halls, bum, 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 it's reflecting that shape. And so we've taken all these versions and we've run them through the Parsons code. And now part of what I did was make this graph based on this string of letters. But I can see these two graphs are very similar. I don't know if I can stretch this a little. I haven't dealt with that. Okay, this one, it's different. It's not quite the same. It left out a couple mountains. That's how I look at it. And that one's pretty close. That's all looking pretty close. That one's a little far away. This one looks very different. It's mostly down instead of mostly up. This one bounces up and down, but ends up a little lower. So this one's all downs. These variations that say they're the same song, some of them are much more similar than others. And this Parsons code thing is to understand that. All right, then the next thing I added in was this notion of quantizing. So what happens there is that sometimes two tunes are very similar, and I've been thinking about if Twinkle Twinkle Little Star, da 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 da, is the same tune as the alphabet song, da 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 da. Well, it's got that elemental P, has extra notes, and so it makes them seem very different if you do the basic graph. But you can do this notion of quantizing and say, I only want you to show me every quarter note. And, if you're doing a bunch of little twiddly eighth notes in the middle, I'm going to ignore that and try and get the essence of the tune. So I do that. I get a different code. The codes are all shorter, but they have a different shape because we're leaving out certain notes. And these are more different. That looks pretty similar, but not quite the same. That's pretty similar. They're a bit more similar across the whole set, but still, I mean, some of these are just different, completely different tunes, and they just look different. So we did that as the second phase of this, and that meant we had to take these numbers. Whoops, like C2, the first version, I was only looking at the letters C, C, G, B, C, C, G, C, B, whatever. This quantizing, I have to look and say, oh, this is 2 eighth notes. That's a quarter note, quarter note, quarter note, quarter note, 2 eighth notes. Well, I'm going to say, let's drop the second eighth note and just look at C, C, G, C and decide how similar. All right. And managing this L:1/8, you could also switch in the middle of the song and stuff like that. So the input format lets you do things, and we're trying to catch up to the input format. The next thing is this key one, and that's the one we're working on now. Like, what key is your song in? Well, this one's in the key of C, and so you can see there's kind of a lot of C notes in it. Okay, that's very common. The key of the song has a lot of the notes from the name of the key, and usually the last note is, often it's the same as the name of the key, or else something in the same chord. But key of C, well, if somebody sings it in C or somebody sings it in B flat, I mean, it's kind of the same song. You know, it's just transposed up or down a little bit. But when you compare, well, the Parsons code kind of takes care of that because it's only measuring ups and downs. And if you started a note lower and you kept the same pattern, it's going to be the same. But other songs might shift some of that around. And so I want to move to handling more of the key changes, driving that. I don't think it affects most Parsons code thing, except if you were changing keys in the middle of a song, it might do a little bit of that. I could imagine starting in C, which has no sharps and flats. Maybe the last note here is an F, and then you switch to the key of G with one sharp, F sharp, and you've actually moved your pitch up a little bit. You've gone from F to F sharp. Even though they both say F, it wouldn't be reflected. It's not the biggest problem probably in all this, but I think because we went through all this work to get this 2-pass thing working for L, and we don't handle key changes in the middle, we should. I wanted to catch that one up for what we're doing. And if somebody put key of F and then down here they put, well, I don't want to leave it in here, but if I put a K:G right here and then go on there, the new notes would be interpreted somewhat differently. And we want to handle that. Okay. So the other thing going with this is this format is so goofy. I don't know, goofy is not the right word. You know, the simple side of it is, it's just the note letters. Okay. But you have all these extra little symbols and the parentheses and all this stuff that have some meaning in general, although we may not care about it for our analysis. But we have to be able to kind of skip over it even if we don't know what it means. Okay. So the 2-pass thing is I first go through and say, this is D and C and D, F, E, D. And I can put the notation, the durations in, but I'm going to ignore these parentheses. And if you did a unit note change in the middle, I need to accommodate it. And that becomes an event, unit note changed. But in my final version of the song, that's not part of standard music notation. That's this input format. So I just want the notes in my song. All right. So I guess where this is, I don't know. I want to do this in a way that doesn't break everything while I'm doing it. Okay. And that's why I'm looking here. I don't have key changes, and I don't even have anything that says the initial, the key is the starting key. Okay, so I can tell we're not quite doing everything there. We allow you to tell the TuneBuilder what the key is, but that's not really right. It's really more like this. The key, the initial state does capture the key. I don't have to put the word self there. It does capture it, but we're not using it anywhere. Okay. So, we want to do that. And I think what I can do, well, I don't know if I have to coordinate things, but I'm going to say the key is initial state key. and that should make it accessible down here. Now, yeah, I'm using it, or I'm declaring it but not using it. I think in here, this note, let's look at note. Okay, we have the ability to do change key on the note, and that's what we should be doing. Every note that's coming in should correspond to the current key of what we're building. Okay, so I want to say key. Well, okay, I'm going to do it this way. I'm going to lie for a minute. Okay, I'm going to say the key is key of C. C is special. The key of C has no sharps and no flats, so I don't have to worry about accidentals. And I'm going to force it. Oh, no, that's not going to work. No, I think I really do need to do both. Okay, I think what I am trying to do is, I want to do a key change key to key. Okay, so I'm going to change. Okay, maybe this is okay. I'm going to change the initial state's key. I think that's okay because all I do is handle the initial key. I'm not quite sure if we get it there or not. If we don't, this will break some tests. If we do, I don't think it's going to affect anything. Yeah, so we don't care about that right now. But I think what I can do, in here, note parser, it was at the bottom, it sets this to tune state key. I think I can make this key of C and kind of default. It's really defaulting to no key, no accidentals. So sort of a default thing. I'm just saying, if you tell me F, I'll say it's F. I'm not going to worry about is it in the key of G or D or E flat or whatever until I get to that second pass that TuneBuilder does. And so again, assuming the input format puts the key in and that gets its way to TuneBuilder and then we can use it. This should be a neutral change, except for one thing. There may be people who are testing the note parser to make sure the key came out right. And they are assuming the key gets done in this file. And so I may have some tests that are making that assumption, but the ones that go through the TuneBuilder should be getting the right notes. Okay, so maybe I can, let me undo that and let's just make sure there's a test at the TuneBuilder level. Open TuneBuilder tests and keep it around. I think I'll even just close that little sidebar for now. Okay. What I want to do is make sure the TuneBuilder applies the key. Okay, so let's add a test like that. Test tune applies the key signature. Yeah, I'm enjoying it okay. It's kind of biggish as languages go. Maybe not as big as C++, but certainly bigger than Java or C#. It has a few little tricks that are kind of nice. It does a bit of functional stuff, which is nice. And it has, like C#, it has extensions, so you can just add methods to classes. But yeah, it's got its quirks. All right. So what we're going to do is, let's see, events ABCD. I guess I need to just, let's do something like that. Let tune equal TuneBuilder reference number 1. And I'm just going to do events. I won't worry about these other things. Events, and then I'm just going to, thank you, take care. Let's see, so I'm going to put an event in, and I'm just going to put one note. Okay, so let's put, oh, I guess I do need to say the key is G. Okay. And then I'm going to put an event in that's one note. So event.note, and it needs a note. Let's do C. Well, let's do F in key, and the key is key dot of G. Oh no, I want to say of C. Okay. Got a bracket here. Okay, so let's get a little spacing here. Well, that didn't help. Okay, so what I'm saying is if you have an F, wow, okay. If you have, if you're in the key of G and you put an F in and you say it's the F in the key, and even if you put the key of C, what I expect back is, come on, if I do tune dot, well, let's do tune dot, no, tune dot, dot make. Tune.notes. I should get back an array, which should be a note F in key of G. Okay, so you build an event that says F in the key is defaulted to C, which is neutral. And then when I get this back, array symbol of, oh yeah, these are symbols. Dot note. Try that one. Okay, so the result of this is a note F in the key of G, because we said the tune should be in the key of G, and so the note should be converted. And let's see if this works. This should work now. Oh, it does not. What did it do? Oh, I need to get a rhythm on there. Note. Oh, okay. I think notes take rhythms too. Note with a rhythm. Okay. I think I just say rhythm. Okay. Yeah. Back here. Key of G, and the discussion around the default note length. The default rhythm is 1/8, eighth note. Okay, so by default you get an eighth note. This should be working. Okay, and it's not. F4 1/8. Okay. Yeah, you know, our note display doesn't show us the key. I think that's probably a flaw, at least for testing purposes. Okay. Open note. Okay, yeah. Um, this is probably more of a debug constraint, but the note, let's see, the key. Well, I don't even remember what keys do for their names. Do they have one? Oh, yes. Okay, so the name is in there. All right, let's put that in the note. Okay. And I think we'll just put it after this in, whoops, in parentheses. Let's put the key dot name. Okay. Now we run that test. I expect we'll find that one of them is in C and one of them's in G. Somebody's probably looking at that description. Okay. Yeah, so we got back a note in the key of C. We wanted back a note in the key of G. Let's see this one. Yeah, he put his key in there. Okay. All right, now our failure is back to this one. We expected G, but we got C. All right, and does TuneBuilder, what does it do with key? Well, it says change key. Oh, self.initial state.key. Okay, now I'm puzzled. All right, so the TuneBuilder, let's see, what did we do in our test? We told it key of G. Yeah. Make that like that. Okay, so we said put this in key of G. Key should be G, and that should be saved in the initial state. If we could have set it there, and then down in complete tune, we look at key here. Okay, so I'm going to break here if I can. Yep. And let's just see what's going on. Okay, so let's print initial state. The key is G. We got F sharp. Okay, 1 sharp, F sharp. Yes, that's right. Okay, and so we step over and let's print the key. Key name will be good. Okay, key is G. Now that gets referenced here. Now let's see the note. Let's break down here. Continue. Okay, now let's look at the note. Okay, it's F in the key of C. All right, so I want to stop in note and take a look at this. All right, let's continue. What? You didn't call change key? That looks like you should have called change key to me. All right, let's kick that off from fresh. Okay, we'll continue. Okay, there we are. All right, let's print key. Print new key. Oh, interesting. It's C. Oh no, it's G. Okay. I guess I should print new key.name. Okay, key of G. And let's print self dot description. Okay, so we think we're an F4 1-1 in the key of C. I don't know what that new accidental thing was about, really. Okay, but let's step over and let's just print accidental is in key. Okay, and if we we'll print key.name, new key.name should be G. Okay, so we should get F in key, whatever octave, key of G, whatever rhythm. Okay, let's step out. And step over. And let's print measure. F418C. It did not change. Okay. Note change key. All right, let's break in here and make sure this thing. Whoops. Times is rhythm. Where's times? Break here. All right. So why I'm confused is I would have thought our change key looked like it produced. It looked like it was going to produce the right thing. And times should do it, but it didn't. It doesn't have the right result. Okay, so I'm going to run the test again. Okay, let's continue from here. All right, now we should see. Well, let's print self. That should be the rhythm, 1-1. Okay. Note change key times. Okay, I guess I want to find a note times, right? Note times keeps everything the same. Okay, let's step out. And we're here. Okay, so print accidental in key, print the key. Oh, look at that, no key. Yep. Okay. Let's make sure we're using everything on this thing. Okay, character accidental, octave, key, and rhythm. All right, I want to try this test again. Try them all. Okay. Oh, interesting. Okay. Oh, these are in the key of G versus C. Okay. But our TuneBuilder test passed, right? Yeah. Okay. So what's going on with the parts parser? All right. So what level are we working at here? We're creating a tune with parse tune, and we expect the notes to be in the key of C. All right, let's see what parse tune says. Oh, it says key of G. Okay. I'm thinking that's actually this is a consequence of the change we're making. We're saying by the time when you parse a tune before you do the TuneBuilder thing. No, is that quite right? Yeah, I mean, we said the tune was in the key of G. It should be G that comes back. Okay, so let's look at parse tune again. Okay, it says make your input be in the key of G and parse it, come back with whatever the tune is. Okay, return to tune. Right. And so this test said those should be in the key of C. That's just not right. If we were talking about the events, they should be in C, but the notes should be in the key of G. Okay. Now, that was everybody. Okay. Let's review this. We got key, initial key. Yeah, it's not changing. That's going to change. All right. But let's go back to the parser. Where's the note parser? Okay. Tune state.key. Okay. Yeah. So at this point, what we've got is TuneBuilder forces appropriate key in second pass. I don't know if I like saying it that way, but that's what's going on. All right. But this should be key of C for now. So this note parser should default to the key of C when it's building things. And I expect this to break some tests because this is a change. I don't know how many, but we'll see. I'll be disappointed if it's 0. Oh, it's 0. Okay, let's see why. Let's take a note parser test. Note with accidentals. Okay. All right, let's put this back. And let's go here. Notes with accidentals, notes with octaves, numbers and slashes. Okay, I don't think we've done an example that's in the key. So let's do that. Oh, we can't with this test, maybe. Okay, it's doing note parser. All right, well, let me just try one. We can see what we can get. Come on, Mr. Editor. Function test note in key. All right, try note with F. In key is key dot of C. Okay. I think that, oh, I gotta capitalize that. I think that is true. Whether I can get that from note, I don't know. Note, okay, we take a note parser, we feed in our string. So where did we get that note parser? Well, we went to ABC parser. Okay. Let's go there. Note parser is note parser with tune state. Okay. So ABC is providing the tune state. Maybe we can set that key. Yeah, somehow I have to force the note parser to operate in the key I want, or at least be aware of it. Excuse me. Well, let's extract out this variable. Okay, ABC parser, and let's tell it dot tunestate dot key equals key dot key of G. I don't think these other tests are going to care. Let's see. They may. We may have to default it. No, the only one failing is this note in key. Okay. Yeah, that's good. Okay, so I'm saying even if the key is G, for now you should be writing a note. You should be telling me it's of C. All right, and let's change this now, and this should make it pass. Okay, and it should all pass. All right, so let's see what we can say we did. Right. Okay. So what we've done is we said make the note parser default all note keys to C. And second pass, we'll put in the real key. Okay. So that's a good step. All right, so remove tune state from note line parser. We now make the parser first pass, put in notes with default key C, adjust to the true key in the second pass in TuneBuilder. Make. Okay. That's what we did. And that was a big step. That shifts us from trying to manage tune state in the parser and managing it in the second pass processing. Okay, there's one leftover piece of that. I think at this point, like, who uses tune state? So let's find that. Find tune state. Yep, we receive it, we save it, we don't do anything with it. Okay, let's take it out. Take it out. That should work. Okay, we should be able to take it out of here. All right, people should complain that the constructor doesn't know how to handle it. Build failed. Didn't really tell me the right place. Compiler is a little flaky. Let's do a clean. There we go. Okay. ABC parser creates a note parser and passes in tune state. Okay. That shouldn't be done. And there's probably some tests that do the same thing, I would guess. There may not be. The one we just did was probably the one that was most likely to. Okay, good. All right, so we remove tune state from note parser. All right, that's a nice step. And I think we may be removing it from the ABC parser at this point too. Okay, so tune state there. Okay, use there. It's set here on the K line. Well, we set it. All right. We set that, but nobody ever looks at it. Okay, so let's take that out of here too. Okay, build should show all those. Yep. Okay, because it was being set but never read, so not much point. Same here. Okay. Build. Run our tests. Gosh, I don't know. This last update of Xcode has just been very buggy. Come on. Oh, maybe it was faster than I thought. Oh, my sound off. Okay. That's all right. Good. See parser dot tune state key of G. Okay, we don't need to set that anymore. Good. All right, so we remove tune state from ABC parser. And that's worth noting here. Okay, so what that gives us is all the tune states being managed in that second pass. Nobody's mucking with it during the first pass. Nobody's trying to track it or do anything with it. That's a good thing. All right. Next stage, I think we handle the initial tune key signature, but we want to handle key signature changes in the middle of the tune. So I think we'll take a break first, maybe 3 minutes, possibly 4, but no more than that, I think, and come back and tackle the rest of the key signature stuff. So allow you to change key signatures mid-tune. All right, see you in about 3 or 4 minutes. Welcome back. All righty. So let's take another look at our definitions here. Okay, so this is the K field. Let's find the other. There's another table that shows every field. Yeah, here we go. Okay, so the K field, file header, no, but tune header. So tune header, it was the last line in the tune header. It can be in the tune body. It can also be inline. So inline is in brackets. Well, I guess we need to make a tune in the middle of a tune. All right. So I guess that's an ABC parser test. Let's find some of those. Good. All right. I don't know. I usually try and put the test before the. Okay. Well, here's L. Maybe L's done down here. Yeah, unit note length in tone header. Okay, let's find K colon. Build songs. Okay. AF in the tune key of G. Okay, yeah, that one checks that the header applies. So that the tune header ends with K colon G, and it makes sure that the F is in the key of G in that one and the C in these two. Yep. Yep. Okay, now let's, then note length. Okay, I think we can put key right in here under this one. Yep. Key changes in body. I think it's probably accurate. In body. And it's going to look a lot like this one. Okay, and if we go to parse tune, key of G. All right. Let's go back. Okay, so key, well, this is key of G. We don't really need any of that. But here, let's change the key partway through. D. All right, and let's just use an F. I really care more about the pitch than the rhythm here. F and F. Okay. F. Let's do C. C in the key of G is just a C, but C in the key of D is a C sharp. Okay, so we are always starting in G, and we're going to put one note and then switch keys and then do the next note. Okay, so I don't care about the rhythms. I just want the tune.notes. So I guess let's just do tune.notes. Come on. Notes, and that should be, whoops. Don't do that. Should be a note. It should be a C in key of G. Oh, maybe I can do this better. Let's do F in the key of G and then switch to C and F again. So it should be F sharp. F in the key of G, followed by note, missing a parent. how annoying. Okay. We're in here. Followed by another note, which is F in the key of C. Okay, this should fail. Hey, I don't need those. Okay. Okay, it fails because we don't handle any of these. F4 in the key of G. Yeah, I'd probably have to put the rhythm. Something's not right there, is it? Let's see what parse tune does. Right, these default to 1-1. I don't think that's necessarily a good default. I don't know. Okay, I'll specify to my test. It'll make my test a little more longer, but yeah, that should fail. Okay. F4 1/8 key of G. F4 1/8 key of G is not equal to F4 G, F4, and C. Okay. We said it should change keys. It didn't. All right. That gives us a good test to cover what we're doing. All right. So if I look at ABC parser, I have my K line. It tries to parse this thing and then set the key. That's in the header, but I don't have a corresponding line in the body because up till now it's been illegal. So let's take this. It won't be quite a fit, but we'll give us a start. Okay, if the line starts with L, well, let's add, if the line starts with K, we're going to try and parse parse with key parser and line, and then set the key in the body. Well, that part's not right. The state is irrelevant. Okay. Why can't I delete that? Okay. But tunes.setKey, well, that's not what we do. We don't just reset the key because the key in the header is the initial key. This is the running key. And if we set key, well, that's only setting the header key. Okay, so we need to do like this one. We need an event. We need an event, basically. And we don't have one right now. Unit node length change. Okay, well, this should be the case of a key change. And the result should be the key. All right, now there should be some complaints because Yeah, we don't have all our switch statement. Okay, so when you give a description, we need to describe what the key looks like. So let's do case key change. Let key, and we'll return key change, and then let's do the key name. Okay, by analogy. Okay. Anybody else? All right. We're not using it yet, so it should still be a failure. Oh, we missed one. Oh, right. In our second pass, we haven't dealt with it. Key change, let key, new key. Okay, that's a bad line. Okay, again, I'm just making things compile first, and then we'll see what we can do. Okay, our test fails. We got 2 failures. Let's check that out. Body info field matched and ignored. Okay. Well, what's your problem? Okay, measure 4/4 A4 key of F sharp F sharp F sharp F sharp is not equal to the key of G. Interesting. Okay, let's check this one. This should be F. Yeah, should be key of G. Wait. C. That's interesting. It defaulted to C now. Before they were both G, so this is really surprising to me. Okay. And I'm kind of surprised this would break. Okay, we said the key was F sharp. Okay, so this is check tune parsing. Yeah, everything here says it should be G. That is wrong. Oh, check tune parsing probably just defaults the keys. Yeah. It says they should be in G. Whoops. Check tune parsing. Expected notes are in the key of G. Expected tune. That's really not. That's really not right. Let's see. Key G matches ignored. I think we should just keep this in G. It doesn't. This test doesn't check the key signature other than the fact that the notes are there. B A. A B C B A. A B C B A. Yeah, this is really checking that. No, wait a minute. Oh, no, this should just go away. This in the old days we were ignoring the K line, now we're not. Okay, so this test should just take that out. We're also ignoring all these other lines. They don't matter, but yeah, I think this should be right now. But this one should be failing. Okay, because we don't handle those key changes, right? So now I'm a little puzzled by why it's C and not G, but let's fix our TuneBuilder. TuneBuilder, okay, and well, we just want to maintain the running state as we go. So the key should be equal to new key. Okay, just like unit note length changes on that one. All right, and this should pass, but I'm a little worried that that C note was wrong. Okay, so it may be something in the test setup is messing it up, but CC is not equal to GC. Okay. Let's make sure we're let's stop here and let's also check key initial state. Okay, test, run that. Okay, so let's see key. Well, we'll do a step over and look at key. This should be G if our test is set up the way I think. Okay, it is not G. So either our test did not set up the right way or we're not handling the initial state correctly. Okay, so that comes to what parse tune does. Well, it sure looks like it should set up key of G. Okay, so let's take a pause at ABC parser and make sure this line's being handled the right way. Let's put it on the next line. Okay. I know I'm spending more time in the debugger today for some reason. Okay, fine tunes, right. Let's print line. Okay, K colon G. Right, it starts with key K colon. We're going to parse it. Let's step into this one. Builders.last.set key. Okay. Step over. Okay, so it's got the title, an A part, key of G. All right, now I'm puzzled. Okay, so I would have thought the key of G, so let's do okay, has no events because the key change is not an event. Only the note becomes an event. So let's go to TuneBuilder. Let's do add. Either of these. We'll continue. Okay. Let's print the events. Okay, that's the note F. All right. And let's print self.key. Oh, self.initial state. Should have key of G. Okay, there's key of G. Okay, I'm going to be puzzled. Did we? Oh, we didn't set it in here. That's why. All right. So in the body, down here we added tunes.add. Here we're calling tunes.set key. That's not right in the body. Oh, that's why the C is there. So before we set the key initially and we didn't do anything on the next key change. now we set it initially, and then on the key change, we're setting it again. Well, that was supposed to be the initial key. Okay. Hey, Eka Chess, welcome. Let's see. So I think basically what we need to do is this same kind of thing. We got to add an event for our key change. And this is key change. And it goes to key. And this is not being done. Okay. This should pass. Let me just clear all these breakpoints. Continue. Okay. Let's see. I'll give you the brief of what we're up to. We're working on this tune program to assess the similarity of different tunes. And we're reading this pretty complicated format called ABC. One of the things it does is it lets you set the key signature, and you set it in the tune header as the last line. And then you're also supposed to be able to set it in the tune body, and we just added that capability. So if you're in a song, some songs, they start off in the key of G, and then they switch to D halfway through. And we need, this notation format supports that. So we're trying to make sure we do too. And then the other thing it does is it lets you do it within the middle of a line, and we haven't supported that yet. So let me mark this one done. So we do support key changes via lines in the tune body. Okay, so we're supporting this format when somebody does K:G in the middle of the body. We switch over to that key at that point. Okay, and then I wanted to just kind of walk through the places we've been touching and make sure that all is looking right. Okay, so with this, the TuneBuilder is going to accumulate all the pieces of information. So it definitely gets the initial key. If somebody changes the key, it gets marked here, and it gets the initial note length and some other things. It accumulates events, and then at the end, it does this complete tune, which we're calling the second pass. So the first pass is generating events. The second pass is turning it into musical measures and notes. Okay, we have the key. We track that. When a key changes, we just change the key, and the next note we'll get the new key. New note length change worked the same. Okay, the only piece I'm not totally happy. This I think could be. It could explicitly be a method to collect the metadata. So let's make a function for that. File private. Gather metadata. So that's things like the tune's name, and it makes a metadata. Well, what does it make? It makes, okay, we're going to have to work on that. Metadata. Let's define a type for that at least. And we can do a type alias. Okay, this thing, put all this in here, and we'll return metadata. Okay, that should work. Oh, I gotta call it, yes. Okay, I'm gonna say metadata equals gather metadata. Okay. Let me move. Well, this should all pass. Okay. I really wish I could get that done automatically for me. Okay, and I want to move this. Since it's being called before complete tune, let's move it up above complete tune. All right, and we also touched the, well, we touched the note a little bit. Times needed to put the accidental octave key in. Key, okay, good. And we touched the ABC parser. I'm not liking where this is going, that we keep doing line starts with this, line starts with that. But I don't have a good way around it. Okay. If line starts with that, okay, so this case here, we added the key change events, but the other place it can happen is in note line parser. Okay, so I'm switching to the next little feature. Note line parser, I don't think I have up. Okay. Note line parser. Okay. Now this one, unit note length parser. Yeah. Right. Okay. So what happens here is you can have bracket k:(g) in here, and it should find that event. So I'm going to make these. They're really called instructions in our format. So instruction equals unit length parser. Length parser. Well, let's get this whole bit in there. Okay, that's really note length parser. Okay. Okay, let unit length parser equals this whole thing. It gives me back and a note length change. Okay, instruction equals unit length parser. Let's make this instruction here. Okay. That's changing my grammar, but it shouldn't change any of the behavior. Okay. All right, that's our grammar change. All right. Now, this happening here. I guess that's okay. All right. Now let's find note line parser tests. Okay, let's make up a situation. Test inline key changes are captured. Okay, and check notes. Let's see what it's doing. Well, it's giving us note names. I really want the events. Okay, so events, I give you a line. You give me back value, which is the events, I guess. Yeah. Okay. So we want to call events. Well, let's let events equal. Can I do that? Events of some line. And I want to assert that the events are there. Yeah, if I just do a couple events. Well, let's do a, well, I don't know. Do we have a key? I guess we don't really care about the key. We're just checking that you put an event change, key change in it when it asks for one. Okay, so we'll just put a note in. A key change to the key of C and another note. All right. And then that should be events should be, well, let's say events of 1 should be dot key change to key dot of C. Okay, so I'm only looking at the one. Yeah, I need to try. I'm not really checking the note ones because I trust they're there. This one is not there, I don't believe, and it should be. Okay, and oh, something else went wrong first. Unexpected input remaining. Okay, that's probably good. Yeah, we see K:(C), and we didn't expect that. Good. All right. So now note line parser. The next instruction is a key change, and the key change is, well, somewhere we have a key something parser. Key parser. Well, let's just start the same way. Key parser nothing dot parser. Pipe 2, and then we can just say event dot key change to the key $0, which is the key that comes back. And that's good. All right, that can fit on one line, I think. Is it really that? little. Okay, so that's a key change. All right, so you can be a unit length parser or a key change. Okay, so before you could only have L colons. Actually, let's put this above. Right, key change, and I'm going to make this one first. Okay, now the instruction is either a key change or a unit note length change, and instruction is still there. Okay, this should pass, I think. I don't think we have to do anything else on this. Right, okay, well that went easier than I expected. Okay, handle inline key changes. All right, let's do some cleanup. Okay, one thing I think I can do is just change this name. I don't think the word parser is really adding much. Okay, so key change or unit length, that's fine. I guess I'm wondering why this is not a parser itself. Well, that is the true parser, I guess. Fair enough. Okay, where's my keychain parser? Just a key parser. Okay, we build the key. That's fine. Key to accidentals seems. That seems like something that could be done statically. Okay, let's see, note parser. Okay. And I don't know, ABC parser, I don't think is not affected because that happens inside the note parser. There's one place I'm still not happy. Well, I don't know. It's an evolving thing, but the complete tune thing is, there's duplication in here. Okay, if measures nil, measures not. Okay, that's okay-ish. I mean, these are two independent cases. They both have to do that. Okay. Anytime you want to put something in a measure, you got to make sure it exists because they can go away when they get closed. All right. And now in bar line, you see bar line, if the measure is not now, you have one open, you need to create a new one, append it. Oh, this is weird, isn't it? Oh, measure. Wait, what's measure? Oh, it's. I'm going to change this to symbols in measure. Okay. Let's make sure that works. Does that explain what's going on here? And that's a renames. Okay, that's a rename. Okay, let's see. Is this any better? This stupid auto diffing thing is just really driving me nuts. Okay. If symbols in measure is nil, so if we don't have any measure going yet, you better start one out. All right. And then you're going to append the symbol to it. That's fine. Same thing here. If it starts out nil, we got to append something to it before we get going. And it's like everybody has to do that, don't they? Except these guys. Does it make sense to be nil? Okay, if it's not nil, for part, you create a new measure with the current partial measure. You append that new measure, and then you reset the symbols in measure to nil. Why nil? Okay, and then here, oh, at the end, we're doing the same thing. Okay, I don't know if can we do this with the fact that the list is empty? Does that tell us anything? It's just so hard to read until I check it in. Alrighty. Okay, what's the consequence of being nil? Does if the symbols in measure is not nil, okay, I think the situation is the first thing you get is a bar line. Then what symbols in measure starts out nil. Okay. So if you get a bar line and you don't have anything in there, then you don't want to create an empty measure beforehand. Okay. That's okay, there's really that first bar line case, but you could have stuff in front of it, so it's not, we can't just assume it's in front. Okay. If the symbols in measure is nil, not nil, we've got a measure, we need to store it. And then we reset this to say, now it's empty again. I don't know. I think I should be able to just, let me try it with empty array. Okay, so if I start out empty, and then I don't think I need to look at this, right? If I always leave at least something going. Symbols in measure is nil, that's not going to be true anymore. Okay, and same thing here. Okay. Don't need the bangs anymore. Okay. Symbols in measure not nil. I guess I want to say if the count is greater than 0, then I'm going to build a measure out of the symbols. And do that. Okay. If it's not nil, did I get that one wrong? Not nil. Dot count greater than 0. Okay. Doing the same thing here. Count to greater than 0. Do this. I'm doing this mechanically, and I hope that's okay. This becomes empty. I'm not going to worry about that one. If symbols and measure dot count greater than 0. Append the measure, create the measure, build a measure, and append it. Okay, does this work? Okay. Make symbols in measure an empty array rather than nil. Okay. Again, I'm hoping I can simplify it and see it better. Okay. Let's take these comments out. So now we're saying we promise there will always be somewhere to put things. All right. So if you see a note, append it. That seems good. If you see a rest, append it. If you see a bar line, if you've got a partial measure, then you should keep it. And if not, nothing happens. If you get a bar line and there's no notes in your measure, I think that's okay. The only case, well, I don't think it's meaningful to have two bar lines. Two bar lines together should mean something else. So I think that's okay. Okay. Measure time signature. All right. That always seems okay. Measure parts. Same thing here. Current part equals part name. And if the part name's not being used currently, that's new to us, then we should start an empty list. Yeah, okay. All right. But the duplication I have is this. Symbols, let's see, is that all completely duplicated? Let new measure equals measure times measure this. Part subcurrent equals dot append measure. Part subcurrent dot append new measure. Symbols and measure equals that. Okay. That also is here. Well, we don't say symbols and measure equals empty, but we could. Let's do that. Okay, and then this thing is let's see if I extract method, what does it suggest? I don't like that. Okay, symbols and measure does need to go in and does change. All right, let me clean out this. Is that still there? How do I have changes when I just check something in? I guess it was deleted. Okay. Sorry, did that not commit? Oh, weird. Okay, I'm gonna quit Xcode. Oh, that thing did get in there. Extracted function. Okay, let's put this back. Okay, so I'm changing symbols in measure. I'm changing parts. Is parts defined in here? It is. Okay. Well, maybe that wasn't so bad. Time signature, current part. I'm not changing current part though, am I? No. It's kind of a, I forget the phrase for this, but it's where you extract out a whole new object. I'm blanking out. I've got a refactoring book here. All right. Yeah. We'll take a look in here. It's something about whole object. Is it introduce parameter object? I don't think that's quite the one. I think that one just builds an object out of parameters, but that's not what I'm. No, there's another. It's a pattern Kent Beck wrote about, and I'm just not getting it. Is that? Yeah, I think if I can remember the name he called it, I'd be preservable object. Is that it? I mean, the situation is you have fields that are only valid for a method, and you want to basically just extract the method into its own object, and that's maybe not. I don't know. That might be the right thing to do here. Method object. Yeah, that's the word I'm looking for. Let's do that. It's a fine refactoring. Okay, so the deal is the TuneBuilder gathers metadata and it gathers events. And so you can see here's the gathering. So that's all kind of this from the first phase. The builder is there ready to go. And then at some point we go into the second phase, and that was this complete, the make here. it says gather the metadata up and build the tune from the events. Now, as I build this tune, I'm finding out I've got this duplication because this chunk of code looks the same like 3 times. And there's some other stuff after it in one case, but it's definitely the same. That chunk is the same there. And because I don't want to like pass in all these arguments, right? It's just obnoxious. So what I'm going to do is say, what if this method was really its own class? Because it really does just take events and turns them into, it takes an initial state and the events and turns them into this parts thing. Okay. And maybe that should be a type alias too, because it's a little bit, let's do that. Okay. So I'm going to say type alias parts equals this. Okay. Okay, and this is also, whoops. This is also now parts. Okay, let's make sure that all builds. Or tests all run. Okay, and I'll do a little diff here. So we've got the type alias for parts. We've removed this extracted function that really wasn't intended to be extracted. And, okay, added type alias for parts, inlined wrongly extracted method. Okay, so the result of this is this complete tune method. If I passed in an initial state, and I passed in the events and I got back this part structure, which contains measures and those contain symbols, it's like, oh, that would all be right. But if I have to do the extracted call and I got to pass in 4 or 5 arguments and some of them are ampersanded, meaning they're input and output and, all that, it really gets messy. And I can't, if I extract a method, well, it gets kind of mixed in with these methods that are more like gathering information. And so I think this complete tune thing is really, like tune from events or something like that. Or it's parts from events. Okay. So let's make a class. We'll extract this into that, and hopefully we can get the initial state in. Let's pass initial state of type tune state. Okay, and the events, that should be good, and we got a caller somewhere. He needs initial state and events. Okay, that should be neutral. It's a private method, so I don't think we have to worry about anybody calling it from a test. Okay, so pass initial state to complete method. No, it wasn't complete. What was it called? Complete tune. Is that right? Yeah. Okay. And I think I'm going to make the names different. This is make metadata. And this is make parts. That should make no difference. Okay, and so we want to extract something that's really events to parts. I'll just call it that for now. And it's in this TuneBuilder area, so it's really tied to parsers. So I'll make a new file, Swift class, event to parts. It'll be a public class. And we're going to give it a method. Well, I think we'll just call it make. And it's going to yield, well, it's going to take initial state of tune state and events of array of event, and it's going to produce parts, which may not be real yet. And let's return this for now. Uses an internal type. Okay, TuneBuilder. Let's make these public. All right, this should build. And let's get that method complete this thing. Okay, I want make parts to have all this. Want too many of these. Okay. Default meter, what is that coming from? I got a feeling that's just a constant in here. And really, it's eventually going to become part of some of this other stuff. But let's take that for now. Okay. All right, so now this thing looks like it's got the right stuff. And I want this. I want this method to be return event to parts of well, I guess this dot make initial state and events, and then all this stuff I'll just comment out for now. Okay, so that we can delete. And then this is well, this is so simple. I'm just going to pass this in here. Copy that. Parts equals event to parts. Okay. All right, so that passes. Let's extract class event to parts. Then I want to do some cleanup and revisit some things. All right, so initial state I think is an okay word over here. Oh, we don't call this ever, so we can delete that. Okay. Let's go to event to parts. I think I would like to make, let's rename this. Well, I don't know. It's okay. I was debating about whether my initializer should just own the creation of these, and I think maybe it should. We need access to events through anything we do, pretty much. So let's make it an init, and we'll give it this stuff. And it's going to store a couple fields. Well, this is really a let. Stupid thing. Initial state of type tune state, and let events of array of event. Okay. Self dot initial state equals initial state. Self dot events equals events. Okay. Now I'm going to take that out of here and in my caller. I'm going to move these two over here, and make takes nothing. Okay, so now we're more in this place. Initial state. I don't know if we care about initial. We're not going to call this thing twice. Okay, there's no harm in it. Okay, so now we had these little clumps of code here. I want to pass them in, but I don't want to pass in symbol to measure and parts and all that stuff. So I want to make sure these things get, I want them to be fields. Okay, so let's do that. Symbol and measure. Well, parts is another good field. Parts. Default time signature. I'm gonna do this. Rename this to state. Self.state equals initial state. Okay, I think that's all right. This should all be fine. We're moving method fields to the class level. And that was sort of the whole point of doing this extract method object thing, to class field level. Okay, so now let's see if I extract these things. Symbols and measure, time signature. Okay, that one's not there. Yeah, I kind of want to change the way this works. I want the initial state. I think I can copy that. All right. I hope I'm not messing anything up. But what I'm thinking is, well, okay, time signature I'm going to pull up. All right, that's another let. Cannot use instance mirror. Okay, let's make this static. Okay, time signature. That's gone here. Unit note length. I want these two. See, I really want you to use state for this stuff. Okay. Let's make sure this works. Let me work on tune state a moment. All right. I think we are at the point that should be a struct now. So originally it was a class because we were using that to modify it and keep the current running state around and do that. But I think it really is a relatively unchanging thing. It will probably change. Well, the key will change usually, but everything else probably won't most of the time, but it will change sometimes. Okay. But I want to make this more of a standalone thing. Okay. And more of a value object is what the struct thing does. Okay. So now I have this initial state. I'm creating a fresh copy of the state. Okay. Parts and events are kind of resulty things. Yeah. Okay. So this unit note length, I think I should be able to just make this be state.unit note length throughout. Okay, so let's see, references to unit note length. Well, mostly it's here and here, and then the change. Okay. Let's find all unit note lengths. Okay, so instead of unit note length, I'm changing state. State. Okay, does this work? Oops, something's complaining. State is a let constant. Okay, I don't want that to be a let constant. I want it to be a var. Okay, so this is a big step. I think we've make tune state be a struct, which is a value object, and make event to part hold track everything in the state. I only did unit node length. I got to do the other one. All right. So unit node length is no longer used. Now let's find key. Key, change key to state.key. Oops. Key change, this is date.key equals, and we're back around, and that's not being used anymore. Okay, that should pass. Okay. Use state for key to. Okay, now symbols in measure.count is a field. Time signature is defaulted, so that's fine. Parts is a field. Symbols and measures is a field. Okay, so I think this could be a method. What the method is doing is well, it's really append current measure, I think. Can you do that? Yes. Append current measure. All right, and that thing, oh, current part is not being tracked. Okay, let's put that up here too. Okay. All right, that should build and run and work. Okay, and then I have two other places that did the same thing. So we'll just call this. This was one of them. And this is the other one. All right. Now let's see what we got. Okay, so event to parts. It has this that it's tracking. The current part, okay. And notice part can change as well. So if it does, that's fine. We reset that. We may have a partial measure or not. That's fine. Parts is nil. Create a new one. Okay, good. All right. So I don't know. This was a fair bit of work, but the real thing was to let me manipulate this as I needed to. Okay, but I think what we have is more compelling to me. Change key and times. Okay, that makes sense. That makes sense. Okay. Hit a bar line, append the current measure. That reads nice and easy. This one, we're setting the part. Let's extract a method for that. I'm going to say switch. Oh, come on. Don't bust on me. Switch to part name. Okay. And again, he's working on these they're now fields, so we can extract, and we can only put the part of interest in the parameter rather than having to list all these pieces of things, you know. So switch to part append the current measure and switch to part. I mean, that reads exactly like I want it to. Okay. So extract method. I think that's all we did there, right? Yeah, that's the switch to, and some reformatting. Okay, so yeah, this is better. Okay, so we start off with that. Excuse me, when we switch parts, we say append the current measure and switch to that part. That makes perfect sense to me. These, I don't know if they're worth a separate method or not. They really are one-liners. It's just a long line. But I think that's worth it. So we do all this stuff, and then at the end we append the current measure if there's anything we gathered without closing it with a bar line. Basically, the format is so flexible, you just have to accommodate stuff like that. Too bad. Okay. I wasn't expecting to do that, but I think that brings out what's going on for this second pass thing better. It really is this event to part conversion that is kind of the heart of pass 2, and I'm much happier with the result here. Okay. I think I'm caught up, right? Okay, good. All right. Well, that takes us pretty well through this today's work. We let me put that in the tracking here. Okay, support key changes in body, and then extract method object event to part, and clean up in there. Okay. And I don't know, the method object thing, I don't use it super often, but it really does result in a cleanup. You know, it takes us from a situation where we had some fields that were used to accumulate data, and then others that were used in the process of updating of calculating that complicated event to parts loop. I think I should call it that. And we split those variables into two sets and put the ones that are related to this in its own class. And that lets us refactor there more easily, and it makes the original object easier to understand too, because it doesn't have to track all this extra stuff. So it's a good change. All right. And I think the extracting we did in there makes it more readable to say, you know, I'm really just appending to the measure, appending the current measure, and that makes sense. Okay. That gives us a good place. I'm not sure what we're doing tomorrow, but tomorrow it'll be at 1 to 3:30 p.m. Eastern Standard Time, or 6 to 8:30 p.m. UTC. Thanks for joining today, and I hope I catch you in the future. Take care. Bye-bye.